Dear all, welcome to this new episode of CATIA Talk for Construction on building performance optimization for sustainability. This topic is pretty important because it will give you the insights on, I would say, system engineering, model-based system engineering for the building optimization when it comes to sustainability. So sustainability is a very strategic topic. And it comes with a very strategic solution, which is MBSC. And this time, we're going to focus specifically on building infrastructures in order to propose eco-friendly solutions that lower the impact of carbon to the general landscape of building and infrastructure. So we will have Benham Avsharpova, which is CATIA Building and Infrastructure Industry Process manager, who will explain you and deep dive into this, I would say, complex topic because it has a lot of ramifications and a lot of different aspects. And it will give you the global overview of what CATIA can do for enhancing that. So thank you for watching this CATIA talk. Looking forward to see you, talk with you on the community, and we wish you an excellent day.
Hello and welcome to my presentation. Thank you for your attention. So today I'm going to talk about building performance optimization for sustainability. So this is about how we can build structures with more sustainability. We can reduce the carbon emission, and also how we can build structures with greener and lower carbon consumption, and also being economic. We don't want to lose money to be green. So at the same time that we can be green, and also we can reduce the carbon emission, also we can make more buildings more economic and more cost saving. So a part of the building, or the reason that buildings are and also structures in large cities, they have more attention, is because there are more people living in larger cities, and we will see that the 75% of the global CO2 emission is coming from cities. So more people in cities, the CO2 emission would be more. So to make the world more sustainable, we can focus on large cities, and especially structures in urban environment. So we can reduce the waste, and also we can use greener sources for energy, like solar panels or solar energy or other friendly sources of energy. But the other hand, we need to find ways to reduce the usage of the energy or wasting the energy. So there are different ways to do that. We can use better materials, or we can use better ways to reduce the amount of energy that we are consuming. In this way, we need to build some simulation models to evaluate what these methods and the methods that we are using, how much they have impact on the environment and the consumption of energy. So we can build different methods and models and simulation models to simulate this and analyze it. So one of the very high level methods is system engineering method for decarbonization. And with this method, first we define our requirements, how much we want to reduce the carbon emission, and then we try different ways to analyze it. And with this analysis, we can evaluate what type of methods or combination of methods would be a better way for reducing the carbon, and also make the our city or structures greener. One of the methods that is developed by Department of Energy is National Renewable Energy Laboratory, NREL. They have developed a tool called Energy Plus. And this tool is providing a software engine for new building and retrofit design, code compliance, green building certification, qualification for tax and utility incentives, and real-time building control and operation. So all of these are in one package developed by Department of Energy. And this tool helps engineers, architects, and researchers to model the energy consumption of the housing projects or residential or commercial structures, and analysis the heating and cooling and ventilation of and lighting of the system of the building, and all of these can be modeled in one package. Now, NREL and on NREL and with this tool, Energy Plus, provided a platform that architects and civil engineers they can analyze how HVAC system can perform and how they can reduce the size of energy consumption of the HVAC system and cooling system. So all of these are packaged in Energy Plus developed by NREL. And NREL also is supporting a large number of smaller companies or startups or private sector that they are developing tools around this Energy Plus platform. So there are several tools that are developed by other smaller companies or other companies in private sector that they provide services to engineers and also architects to design their structure or building greener and with lower energy consumption, so they can choose better materials or better tools to for cooling and HVAC system. This tool is providing a very nice graphical output that it can show over the time, over a year or over a month or a day. They can how much energy is consumed in different locations of the building, how we can reduce the energy consumption in different zones, and we can kind of analyze the whole control system, windows, blinds, solar panels, all of these type of tools that we are using to in the building to see how they have impact on the energy balance in the building and how they can reduce the energy consumption in a structure. So one of the tools that we provide from Dassault Systems is called Daimola. It's a 1D simulation tool, multi-physics and multidiscipline tool, and it's very efficient tool that is a backbone of many of these type of analysis. Actually, this tool is using modelical language, and modelical language is used in many of these type of tools that are developed by Department of Energy or national labs. Modelica is a quiet, efficient tool, user-friendly, and easy to implement. Uh, Daimola is based on Modelica. So it's using Modelica, which is equation based, it has many frameworks and is a causal language. And for the same reason, Daimola is quite efficient and also user friendly. Now, the same Modelica or language and Daimola is used by national laboratories like Berkeley Lab, and they have developed Building Library. Building Library is similar to Energy Plus, is a tool that is an open source library that can be used by energy engineers and architects and also system engineers to define and design control system for energy storage, energy distribution, and also decarbonization energy systems in existing buildings or buildings that we want to plan and design. So these type of models include like cooling system, HVAC system, heat transfer simulations in different scales, a small scale or very large scale, and also control system, multi-zone airflow and cooling system, and also electrical distribution system over a very large multi-grid system to analyze how we can have multi-sources for energy generation, and also knows that they are consuming energy. So we can create a network of energy generation and consumption and analyze it for data centers, commercial buildings, or residential projects. And there are tools developed by University of Colorado Boulder. This tool is called Sustainable Building and uh, developed by Department of Architecture in University of Colorado. This is also open source modelical library that contains modeling frameworks and component models for designing communities that or communication systems that they are developed for decision making in future of connecting communities. So if we are developing a city or a small village or a, kind of like a community, we can define how the energy is consumed in the community. If there are some schools, supermarkets, shopping centers, and also residential areas with different type of zoning, like uh, multi-family, so like housing or like a residential like zoning, we can define how the energy should be consumed, and also how the energy is distributed in communities. There is also a library developed by, again, University of Colorado Sustainable Building and Society Laboratory. This tool is also based on Modelica language, and it has developed actually a village that is self-sustainable, and it doesn't need energy from the other sources. And this is actually a green village that is generating the energy among the community and also consuming in the community. So the community is actually self-sufficient and is not using energy from outside. This is also developed a village in reality, in real world, in uh, Anna Maria Island in Florida. So the tool that Daimola is providing is actually user friendly. As you see, we can develop multi nodes for energy generation like wind turbine or solar panels, and then we can analyze power plant, and we can analyze how the energy is consumed in like a residential projects or like a city framework. We can analyze how the energy is generated over the time and also is consumed, so we can have a sustainable sources of energy like the wind turbine or solar panels, and we can be sure that we can store the energy for different hours of the peak usage, and we can analyze how much energy is used in different hours to be sure that this energy is stored uh, properly and can be consumed by different like consumers. So this is also we have developed on the 3D experience platform some system engineering methods that we can analyze, for example, how the heat is generated and consumed in like factories or like industrial projects. So we can analyze how much energy we need for that factory, how we can use green energy sources like wind turbine or solar energy, and then how much energy is consumed for different aspects of the design and also manufacturing. So we may use more eco-friendly materials that they are consuming less energy, they are generating less CO2, and also they are using less resources from the community or from environment. So with this, like different type of packaging, different type of materials, or different manufacturing method, we can analyze how much energy we are consuming, how much energy is, and also raw materials and resources are wasted and reused in the process of manufacturing. So the designer or the manufacturing engineer can decide what type of method or process should be used to reduce the amount and consumption of the energy. So not only for residential, we can provide methods to reduce the energy consumption and also waste generation of the waste material. We can do the same method for manufacturing and also production of different goods that we see in like production from different companies. So if we are manufacturing an airplane or a car or like furniture, we can see how we can use different methods to reduce the amount of energy we are consuming to produce that product, and also we can see how much materials are wasted or what would be the impact of that product on the environment to reduce the amount of waste material that it would be generated and would have impact on environment. Thank you very much for your attention. Have a good day.